Hi guys, this is Mrs. Allison. Today we are going to extend the idea of simplifying rational expressions to include dividing rational expressions. And this is going to be very similar to the multiplying rational expressions that we did last week. Now, if you have not done simplifying or multiplying, you need to go back and do those first. This won't make as much sense without those two. So, dividing fractions. Let's start back in 4th, 5th grade when we worked on dividing fractions. Do you remember how to do it? Do you remember that dividing fractions, we need to multiply by the reciprocal? What does the word reciprocal mean? So we need to multiply by the reciprocal. Reciprocal means we flip our fraction. Remember, we did reciprocals back when we talked about perpendicular lines like forever ago. Those are reciprocals. When we flip a fraction, when we take what's in the denominator and make it the numerator, and we take what's in the numerator and make it the denominator. Now, does that mean we flip both fractions? No, it does not. Now, some people like a mnemonic device, a way to remember what it means to divide fractions. And you have probably heard the phrase copy, dot, flop. Okay, so what does copy, dot, flop, I don't like that Y. What does copy, dot, flop mean? Well, it means that we are going to take and copy the first fraction, put a dot, because what does a dot mean in math? It means multiplication, which is what this says. And then flop. Well, really, there's no word that means flop. It's just a way to remember that reciprocal flip-flops the fraction. And so to make it rhyme, we say copy dot flop. So let's look at what that looks like in terms of a problem. Okay, so this first problem, good old basic math. 2/3 divided by 1/5. If I'm going to multiply by the reciprocal of that second function, what I'm going to do is I'm going to copy the first one, 2/3. I'm going to put a dot because that represents multiplication. And then I'm going to flop the second fraction. I'm going to multiply by the reciprocal. So we get 2/3 times 5/1. Okay, so let's go back and remember how we multiply fractions. What do? Right, we just go and multiply straight across. So we're going to multiply the 2 times the 5 and the 3 times the 1. So we get 10/3, and if I could simplify it, I would, but 10/3 is my final answer there. Okay, so let's make it a little more complicated, a little more fun. If I go and multiply by the reciprocal here, I get 15/14 times, the reciprocal would be 35/21. So I have copied my first fraction, I put a dot to represent multiplication, and I flopped my second fraction, meaning I'm multiplying by the reciprocal. Okay, what did we talk about in the last video that would be better to do rather than just multiplying these straight across? Because I don't really want to multiply 15 times 35 or 14 times 21. Remember, we can take and simplify each fraction. So let's rewrite this fraction in terms of factors. Well, 15 is 5 times 3, and 14 is 2 times 7, and 35 is 5 times 7, and 21 is 3 times 7. So if I go through and reduce these, I know I have, I have a 3 and a 3. Remember, it has to be common in the numerator and denominator. I have a 7 and a 7, although I could have used that 7 in I could have used the 7 that's down here with this 7, but I can't do all 3 because I only have 1 in the top. So I can only cancel out with 1 in the denominator. So this is what it looks like. And simplifying this, we get, oops, I do not think I left myself enough room, 5 times 5, which is 25, over 2 times 7, which is 14. That's a lot easier to look at than it would have been if we had done 15 times 35, which is 525, over 14 times 21, which is 294. Okay, so much easier this way. Do we feel comfortable with dividing fractions so far? Okay, so let me give you 4 steps we're going to go through to be able to divide rational expressions. Okay, so to divide rational expressions, we're actually going to do it in a slightly different order than we did multiplying. And the reason for that is because of the division. When you're doing mixed problems, meaning they're all mixed together, you're going to want to really pay attention to which ones are division. You have a homework assignment later this week that has both multiplication and division. If it were me, I would go through and mark my division first, because we're going to do one step first so that then we could do all the problems the same way. And that first step is we are going to divide like normal fractions. Okay, so here's what that means. I want you to do your copy.flop. I'm going to abbreviate that. I would like you to do your copy.flop first. The reason for that is because once it's in the multiplication, if we've gone through and done all this work of factoring and we see factors that are the same in the top and the bottom before we flipped it, it might be tempting for us to start canceling things out that don't actually belong being canceled out. So I would divide like normal fractions, copy.flop first. Then what I would do is I would factor each numerator completely. Let's see how quickly I can write this. Factor numerator completely. And then I would factor my denominator completely. Because it's already flopped, I don't really have to worry about much. And then what I'm going to do is I'm going to cancel out or cross out any factor if it's in the numerator and denominator. Okay? So I'm going to say cancel common factors in numerator, and denominator. I'm going to abbreviate those. So I want to cancel out any common factors in the numerator and denominator once it's been factored completely, because I've already done the copy.flop first. Okay, if you need to pause this, rewind it, watch that again, feel free to do so. But let's move on. Okay, so let's look at what it looks like when we are dividing fractions. First of all, I know this is a dividing fraction problem because of the division sign. I'm going to pay attention to that. Because that means my first step is to copy my first fraction, put a dot to represent multiplication, and I'm going to flop my second fraction. Notice I haven't factored anything yet. Notice I haven't tried doing anything other than just the copy.flop. It's because I don't want to lose that term. Okay. So now the directions say to factor the numerator completely, factor the denominator completely. Those are my next 2 steps. I kind of do those 2 steps all at the same time. That's up to you, but I like to do everything all at once. So I'm going to start with my top fraction here, my x. There's nothing I can do there, so I'm just going to call that x. And my bottom fraction here, I have x squared plus 3x plus 2. Is there a greatest common factor? No. Is it a trinomial where where a is equal to 1? And the answer is yes. So now I'm going to factor this. You can use Xbox. I just like to look for what numbers multiply to c, so in this case 2, that add to 3, my b term. So for my purposes, I know that 2 and 1 multiply to give me 2 and add to give me 3. Okay. So now what I'm going to do is I'm going to put my dot and I'm going to factor the next fraction. I'm going to start in the top and do x squared minus 3x minus 4. So is there a greatest common factor? No. Is it a trinomial where a equals 1? Yes. Okay. Either Xbox or just the idea of what multiplies 2 and adds 2. So I'm going to multiply to -4, which means only one term is negative, but I need to add to -3. So multiply to 4, negative 4, add to negative 3, I'm going to have x minus 4, x plus 1. Negative 4 times positive 1 is negative 4. Negative 4 plus 1 gives me my negative 3, so that's factored. All right. Next term, x squared minus 4x. Is there a greatest common factor? Yeah, there is in this one. This one I can pull out an x, and it leaves me with x minus 4. Now comes the part that I think is fun, the part that allows me to cancel out my common factors in the numerator and denominator. So I see an x plus 1 in the numerator and an x plus 1 in the denominator. I see an x minus 4 in the numerator and x minus 4 in the denominator. I also see an x in the numerator and an x in the denominator. Okay, well, look at that. When I'm canceling these out, I can do that because they just equal 1. 5 divided by 5 is 1. 2 divided by 2 is 1. X divided by x is 1. X plus 1 divided by x plus 1 is 1. So I can cancel these because they all equal 1. So what I notice now is that the top, because it disappeared, nothing is left. It means when I multiply all of those straight across, I get 1. It's not that everything went away. It's not that it's 0. It's that it's 1 because everything factors to be 1. And the only thing that's left in the bottom is an x plus 2. So this 1 over x plus 2 would be my final answer for that simplification. Okay, so what I would like you to do, if you feel comfortable, pause the video and try the next one and see how you do. Okay, hopefully you had a chance to try the problem. So the first thing you should notice is that it is a division problem. And the first thing I need to do in division is to do my copy dot flop. So let's go through and do x squared minus 8x minus 9 over 3x plus 3. Dot to represent multiplication, and I'm going to flop my fraction x squared minus 1 over 5x minus 45. Notice I did no factoring at this point. I just think it's better to get it all flopped, put it in the right format first, and then deal with your factoring. That's just my opinion. Now, I'm going to go a little bit quicker through the factoring since this should be review at this point. I notice my top fraction here is a trinomial, excuse me, where a is 1. So I'm going to factor that to be x minus 9x plus 1 over, and I notice in the denominator here I do have a greatest common factor, and that's a 3, so it leaves me with x plus 1. And then let's go to my other numerator, x squared minus 1, I know is the difference of two perfect squares. So I have x plus 1, x minus 1, oops, there. And then the last denominator, I notice again has a greatest common factor. So I'm going to take out a 5, and that leaves me with x minus 9. All right, so now let's go through and reduce the like terms. So I see an x minus 9 in the numerator and x minus 9 in the denominator. And I see lots of x plus 1s, but only 1 in the denominator, so I can only cancel out 1 in the numerator. It doesn't really matter which one, just that I'm canceling 1 out. And now, because it's multiplication, I'm going to multiply it like normal fractions and just multiply straight across. And again, I'm not going to FOIL these together. I'm just going to multiply what I have straight across here. And so what I get is x plus 1 times x minus 1 over 3 times 5, which is 15. So this would be my final answer. How'd you do? Okay, remember on our multiplying rational expressions, we had a weird case at the bottom we talked about. We're going to look at a problem that has that. Okay, if you'd like to pause the video, this would be a good time to try this problem on your own, see how you do. And here we go. I'm going to first notice its division, so therefore I'm going to take and I'm going to copy dot flop. So I get 16 minus 8x over 2x squared plus 10x times x squared plus x minus 20 over x squared minus 6x plus 8. Okay, so now I'm going to begin my factoring. Again, I'm going to go a little bit quicker. I'll slow down when we get to that weird case. In my first numerator, this 16 minus 8x, I know I have an 8, a greatest common factor, which leaves me with 2 minus x. In the denominator, I have a greatest common factor of 2x, which leaves me with x plus 5. In the numerator here, I have a trinomial where a is 1, so I get x plus 5 times x minus 4. And in my last denominator, I have another trinomial where a is 1, so I get x minus 4, x minus 2. Okay, here we go. Let's cancel out what we know. I know I have an x plus 5 and an x plus 5, an x minus 4 and an x minus 4. I even have a 2, which goes into 8 4 times, so that can be reduced. Now, remember the weird case. The weird case is the one where we have a 2 minus x and an x minus 2. Do you remember what that reduces to be? It doesn't reduce to be 1, but it does reduce. Hopefully you remember it reduces to be negative 1. So I'm going to cancel this out and write negative 1 here to remind myself that I need to include that negative 1 when I go to multiply the normal fractions. Okay, so everything has been reduced that can be reduced, and now I'm going to look across the numerator and I'm going to look across the denominator and see what's left. And what I see in the numerator is a 4 and a negative 1. So if I multiply those together, I get negative 4. And in my denominator, I see nothing other than the x that's left. So negative 4 over x is my final answer. How'd you do? Okay, try this last one all on your own. See how you do. So pause the video, give it a second, try it, and then come back and check your work. Okay, so hopefully you've had a chance to try this last problem. Again, I'm going to cruise through it fairly quickly. I have division, so the first thing I'm going to do is copy dot flop. So copy my first fraction. Okay, and then I'm going to multiply, that's the dot, by the reciprocal, that's the flop. And so we get x squared minus 10x plus, I didn't leave myself enough room, 24, sorry about that, over x squared minus 7x minus 8. Perfect. Okay, now I'm going to go through and factor. And these are all trinomials where a is 1. I don't have any greatest common factors. I already checked that out. So I'm going to just go through and factor these. So we get x minus 8 over x plus 3 over x minus 4, x plus 1 times. This will give me x minus 6, x minus 4 over x minus multiplies to negative 8. So x minus 8, x plus 1. Okay, now I'm going to look for my common factors. Well, I have an x minus 8 and an x minus 8. I have an x minus 4 and an x minus 4. I have 2x plus 1s. Do these cancel if I have one here and one here? Nope, because they need to be one in the numerator and one in the denominator so that they divide out evenly. So since nothing else cancels, my answer's kind of messy for this one because it's a lot of terms, but I get x plus 3 times x minus 6 when I multiply the top over x plus 1 times x plus 1. We could write x plus 1 squared if we wanted. And this is an acceptable answer. I don't need to go through and FOIL those together or multiply them together. How'd you do? All right. Make sure you go and try the practice problems on the assignment just to see how you can do. Feel free to rewind, watch this video again if you need to. No harm in that. And then again, email me if you have any questions. We will see you next time.